Good morning, students. Uh, Today it will be our fifth lecture for petroleum refinery and petrochemicals. So, in previous class we have discussed regarding the atmospheric distillation tower or the crude distillation tower. Uh, what are the overviews? What are the basic concepts of atmospheric distillation unit? And what are the process description of that atmospheric distillation unit? And what are the products which are coming out from the atmospheric column? That was unstabilized naphtha, which consists of LPG, light naphtha, and light gases. And then we had intermediate naphtha, uh, which is for the temperature in between 135 degrees centigrade, and the heavy naphtha. Uh, Next, kerosene, light gas oil, heavy gas oil, reduced crude oil. So these are the products are coming out from the atmospheric column. And today we will discuss is whatever the heavier one which need to send to the vacuum column. Okay. So whatever the bottom product of the atmospheric column, it has to fractionate it in the vacuum distillation column. So distillation under this vacuum permits fractionation at lower temperature. Okay. So distillation under this vacuum condition which permits the fractionation at lower temperature, which which helps to avoid cracking. Okay, which helps to avoid cracking of the reduced crude and cooking of the furnace tube. So avoid the cracking of the reduced crude and the cooking of the furnace tube. So today we'll discuss the vacuum distillation overview and the process description. So what are the products of the vacuum distillation column? The products will be light gas oil, heavy gas oil, reduced crude oil, light vacuum gas oil, and vacuum residue. Okay. So from this vacuum column, whatever the products of various streams coming out, having different boiling temperature and having different hydrocarbons and having different carbon numbers, it has to send to different separation unit or the treatment unit. So sometimes it has to it needs to send to the catalytic cracking unit, mainly the fluid catalytic cracking unit, then the hydrocracking unit, or then or the vis breaker unit. Okay. So here it is a schematic of a vacuum distillation tower where atmospheric residue from the atmospheric distillation it fed to the vacuum distillation column, and from where the vacuum gas, light vacuum distillate, heavy vacuum distillate, and the vacuum residue are coming out. Now to recover distillates from this reduced crude, vacuum distillation is utilized. Now by reducing this operating pressure, further distillates are recovered at lower than the cracking temperature. Okay. Lower than the cracking temperature, because we can reduce the temperature by producing the vacuum inside this column. And vacuum unit generally prepare feedstocks for fluid catalytic cracking, hydrocracking units. And main distillates from vacuum units are called vacuum gas oil or VGO. And this vacuum column bottom is known as short residue. Okay, so whatever the product is coming out from the bottom of the vacuum column is known as short residue. Next is some more points regarding this overview of video. First, the process means these operations inside this vacuum distillation takes place in one or more vacuum distillation tower. Okay, so this separation process takes place in one or more vacuum distillation towers. It based on your feed, means it based on your that reduced crude. What types of reduced crude are produced from that atmospheric column? Now second one is the principle of vacuum distillation, which resembles those of the fractional distillation except that the large diameter columns. Okay, these are mainly used to maintain the comparable vapor velocities at the reduced pressure. Okay, so vacuum distillation resembles those of the fractional distillation except the large diameter columns, and these are used to maintain to comparable vapor velocities at the reduced pressure. Next is the internal design of some vacuum towers are different from atmospheric towers in that random packing and demister pads which are used instead of trays. Okay. Sometimes in these vacuum distillation towers, so in the atmospheric distillation towers, so somewhere we use the tray, somewhere we use the packing elements, and here in the vacuum distillation tower some different types of packing which we used. First one is the random packing and another was the demister pads, which here it is look like this demister pads. It as its name indicate, demister means whatever the mist are produced, it helps to reduce that mist. Okay, means whatever the liquid droplets, what are the vapor droplets, okay, are formed in the column, it reduces that by using these demister pads. Okay, so these are used instead of the trays inside this vacuum tower. Next is a typical first phase vacuum tower may produce gas oils, lubricating oil base stocks, heavy residual from for propane deasphalting. So as I have mentioned that it may produce gas oils, lubricating oil base, and the heavy residual which is used for the propane deasphalting process. And the second phase tower operating at lower vacuum, which may distill surplus residuum from atmospheric tower and which is not used for lube stock processing, and extra residuum from the fast vacuum tower not used for deasphalting. So this second phase tower operating at lower vacuum. Second phase tower is operating at lower vacuum and which is not used for lube stock processing, and extra whatever the extra residuum from the first vacuum tower, that that uh, that specially not used for the deasphalting process. Whatever the second whatever the uh, means the extra residuum from the second phase tower we are getting, that is used for the propane deasphalting process. And next, the vacuum towers, it's are typically used to separate catalytic cracking feedstocks from surplus residue. Okay. So here some another overviews where the furnace means before that vacuum distillation unit. Here also we need to produce one furnace to raise the temperature of the feedstocks. So here the furnace outlet temperature are usually in the range of 388 to 454 degree centigrade, and pressure in the flash zone is around 25 to 40 mmHg. Okay, so 25 to 40 mmHg for the pressure in the flash zone. So and the effective pressure for the hydrocarbon vaporization is reduced by using stripping steam. Effective pressure of hydrocarbon vaporization is reduced by using stripping steam in the furnaces as well as at the tower bottom. Steam added to the furnace increase the velocity of the fluid. Whatever the steam we are using in the furnace, which helps to increase the velocity of the fluid, and we as the velocity of the fluid is increasing, which helps to decrease the coke formation. So if we uh, decrease the coke formation, then then the next process, whatever we have, that the catalytic process, so there will be a less generation of this coke formation, that is the less decomposition, the deposition of the layer of the coke over that catalyst surface. So if we increase the steam, if we increase the steam added to the furnace, and the velocity of of that fluid will increase, okay, which helps to reduce the coke formation. And the steam consumption is usually uh, means 10 to 50 pound per barrel of feed, and lower pressure in the tower increase the diameter of the column. This also we have discussed in the last class, how the pressure is related with the diameter of the column. So lower the pressure in the tower, increase the diameter of the column, and higher pressure increase the boiling temperature and difficulty of separation. High pressure increases the boiling temperature, okay, and difficulty of separation. And next one, the vacuum distillation column have large diameter, and the diameter may easily reach up to 40 feet. 40 feet diameter, sometimes it reach. And next is the process description for this vacuum distillation unit. Here we can see that the before this vacuum distillation unit, there is a furnace from where that the atmospheric residue pass through uh, the tube, which is in, inbuilt in that furnace, to raise the temperature up to through 340 or the 380 degree centigrade. And then uh, means at the top of that vacuum tower we have that demister pads, which eliminates that the mist formations, and then it sent to the condenser, and then again it overhead drum, and from the overhead drum we from the bottom we get the process water, and from the top we get the non-condensable hydrocarbons. And inside this vacuum distillation unit, we need to maintain the pressure in between 25 to 40 mmHg. So the atmospheric residue can be sent directly to the vacuum unit after heat extraction in the crude preheat exchanger train. Okay, so what is that this crude preheat exchanger train? What does it mean? Means here it is mentioned that the atmospheric residue can be sent directly to the vacuum unit after heat extraction in the crude preheat exchanger trains, because here also we, before that vacuum distillation unit, there is furnace, and before that furnace somewhere we need to provide some heat exchanger also. So when we provide that one, so it helps to remove the heat of the crude, okay. And if it is sent to the storage, the temperature should not below 150 degree centigrade. Why? To control the viscosity necessary for proper flow. Because to control the viscosity, because if the viscosity will more, then it will hamper the flow, means through the pipes or the tubes. So if it is sent to the storage, the temperature should not below 150 degree centigrade to control the viscosity necessary for proper flow. Then it is heated in several heat exchanger by the hot products and the pump around of the vacuum unit. Then final heating is 380 to 415 degree centigrade in a fire heater. Next point is to minimize the thermal cracking and coking process. So as we are producing the vacuum inside that column, so it helps to reduce the temperature. for the separation. So as it reduces the temperature, so it helps to minimize the thermal cracking and also the cooking. So steam is injected in the heater tube process, and then feed enters vacuum tower at the lower part of the column. Vacuum distillation columns are equipped with a packing for fractionation and heat exchanger zone, and this is in order to reduce the pressure drop in the column, which is necessary for creating a low vacuum in the lower section of the column. So these 7 and 8 number points are very important, because vacuum distillation columns are equipped with packing for fractionation and heat exchange zones. Okay, means these columns are equipped with the packing in where the mainly the fractionation and the heat exchange are occurring. Okay, mainly means where the main mass transfer and as well as the heat transfer occurred. So in that section we need to provide that packing. So inside this vacuum distillation column, and this is in order to reduce the pressure drop. Okay, so this packing is need to provide in the fractionation and the heat exchange zone to reduce the pressure drop in the column, which is necessary for creating a low vacuum in the lower section of the column. And the bottom zone is equipped with the valve trace. Okay, and the bottom zone of this column is equipped with a valve trace. Now the vapor from that flash zone go through a wash and fractionation zone, where the heavy ends are condensed with high vacuum gas oils as a reflux. Okay, so the vapor from the flash zone, it go through wash and fractionation zone, washing by that steam, means whatever the steam we are incorporating before that furnace. So these vapors from the flash zone go through a wash and fractionation zone, where the heavy ends are condensed with high vacuum gas oil reflux. And further up the column sections, these column sections, which is consisting of heat exchange and the fractionation zone, are separated by sprays of liquid from the pump around or the internal reflux. Okay, so inside this vacuum column, as we have mentioned, there are a zone which consisting of heat exchanger and with heat exchange and the fractionation zone, and which is separated by sprays of the liquids from the pump around or the internal reflux. So these zones are separated by spraying the liquids by that pump around reflux, uh, means pump around reflux conditions. Okay, so these vacuum distillation units have a system to create the vacuum that uses either ejectors or a combination of ejectors and a liquid ring pumps. So these vacuum distillation units create vacuum. Here we can see there is a combination of one ejectors with a liquid ring pumps. This is a special type of vacuum pump which also helps to create the vacuum, and for this ejectors also helps to reduce more vacuum. Okay, so these ejectors sometimes there is a ejectors only, and somewhere there is a combination of ejectors and as well as the liquid ring pumps. These two or any single one of this equipment helps to create the vacuum inside the vacuum distillation unit. So these are the two things which helps to create the vacuum inside the vacuum distillation units: ejectors and the liquid ring pumps. Okay. So these ejectors recompress the gases. Ejectors recompress the gases through a nozzle where the vapors from the column are sucked into the venturi sections of the nozzle by a stream of medium or low pressure stream. So we know the venturi principle from the fluid mechanics. So here the ejectors recompress, means already the things are compressed condition, that the ejectors helps it to again uh, to help it again compress the gases, and through a nozzle, and it pass through a nozzle, means that vapors pass through a nozzle from the column, and then again it sucked into a venturi section of the nozzle by steam which are having a lower pressure stream. Okay, so this vapor phase at the ejector exit is partially condensed. Okay, the this vapor phase at the ejector exit is partially condensed in an exchange with cooling water. So this there is a, as we know that there is a two types of condenser, total condenser and the partial condenser. So this partial condenser helps us to create a system, equilibrium conditions. Okay. So whatever this vapor phase from the ejector exists, it is partially condensed, and this liquid phase is then sent to the overhead drum. That overhead drum, this liquid phase is sent, and the vapor phase goes from the condenser to another ejector condenser stage. Means the means whatever the vapor means goes from the condenser, means the remaining vapors, which again sent to the another ejector for further condense, and the liquid ring pumps, which are similar to the rotor gas compressor. Okay, uh, means this is a special type of pumps which is similar to that rotor gas compressor, and this one pump can replace two or three stages of ejectors in dry or wet type vacuum distillation. So this one pump, liquid ring pump, can replace two or three stages of ejectors, okay, in dry or wet type vacuum distillation. So they do not use steam and can significantly reduce hydrocarbon rich aqueous condensate in a system using ejectors, and system with ejectors are much more flexible. Systems with ejectors are much more flexible and rapid to put into operation, and this higher investment required by liquid ring pumps are offset by reduced steam consumption and lower installation costs. So here means from this 16 to these points, that the vapor phase goes from the condenser to the another ejector condenser stage, to these liquid ring pumps are similar to the rotor gas compressors, and then these all these ejectors and the liquid ring pumps, means those combinations, and means itself the ejectors, means which helps to create the higher investment required by the liquid ring pumps and offset by reduced steam consumptions. These are very important points. So there are few questions can come. So these are the things is very important, ejectors and the liquid ring pumps. So few more important points of this video, means whatever the gases produced at the top of the column are sent to the fired heater and burned to release heat. So whatever the gases produced at the top of the column are sent to the fired heater and burned to release heat. That is, we sometimes see see that in the refinery there always a chimney uh, uh, where flame is uh, means the burning. Okay, so these are whatever the extra gases are producing, it burned over there. So gases produced at the top of the column, which is sent to the fired heater and burned to release heat, and the gases separated from the sour water in foul water stripper are sent to the flare system. Part of the water recovered in the stripper is sent to the desalters. Okay. So vacuum gas oil produced may be sent to hydrocracking, catalytic cracking, or lube oil processing sections. So vacuum gas oil produced may be sent to the hydrocracking, catalytic cracking, or the lube oil processing sections. And it is essential to design the fractionator towers, overhead lines, and condenser to minimize the pressure drop between the vacuum inducing device and the flash zone. Okay. So it is very essential to minimize the pressure drop. Minimize the pressure drop between the vacuum inducing device and the flash zone. Next, a few millimeter decrease in pressure drop will save many dollars. So our main motto is to reduce the pressure drop. If we reduce the pressure drop, we can reduce the tower diameter. So as few millimeter decrease in pressure drop, that will save many dollars, because uh, if the pressure drop is decreased, so there is a decrease in the uh, size of the uh, diameter also of that column, and the structure packings may be employed in the column as having high HTP and offer low pressure drop. So structure packing may be employed in the column which are having high HTP. HTP means high equivalent theoretical plate, and offer low pressure drop. So if our motto is to reduce the HTP. Okay, HTP. So means the structure packing. Structure packing may be employed. Means the structure packing is some special types of packing which improves the mass transfer. Means it provides more with the interfacial area in between uh, that vapor and the liquid, and which helps to increase the mass transfer as well as the heat transfer. And this employed uh, is with high HTP and offer the low pressure drop, the structure packing. And this desired operating pressure in column is maintained using steam ejectors and barometric condenser or vacuum pumps. Uh, this will be pumps, not means. Barometric condenser, the vacuum pumps, and the surface pumps and the surface condensers. And so and for a flash zone, pressure of 25 mmHg. Three ejector stages are usually required, and in the flash zone where the pressure is need to maintain 25 mmHg, there three ejectors may be required, and vacuum produced is limited to the vapor pressure of water used in that condenser. The vacuum produced is limited to the vapor pressure of the water used in the condenser. Next is lube oil processing. As we have mentioned that the means this VGO, vacuum gas oil sent to the with the hydrocracking or the catalytic cracking or the lube oil processing units. Okay. Now this is the lube oil processing. Means first the atmospheric residue, it from the atmospheric residue it is sent to the vacuum distillation tower, and from the vacuum distillation tower there is a vacuum column top product and the vacuum residue as a heavy product, and this vacuum residue go through a deasphalting unit where the propane and deasphaltings are separated. So from there, deasphalting unit, it is then solvent extraction process, because in this propane deasphalting unit, there is a propane and the asphaltenes are separated, and when means after after that we need to again solvent need to means need to separate the solvent by using that solvent extractions, where the aromatics and the non-aromatic raffinates are extracted, and then again after solvent extraction it is solvent dewaxed, means dewaxing processing is going on, and then the tertiary treatment, the clay treatment process, means whatever the dewaxed oil is produced from the dewaxing process, it is then further treated with the clay for producing the lube oil, uh, and means and whatever the slacked wax which is from the dewaxing process, it is sent to the de-oiling process to recovered to separate the recovered oil and the wax. Okay, so from this vacuum distillation, whatever the vacuum residue or the means uh, goes to the deasphalting process, and there is some neutral stock which is coming out from the vacuum distillations. So vacuum residue and the neutral stocks, mainly your vacuum gas oils. So these vacuum gas oils and the residuum, as vacuum residuum contains the asphaltenes and the some parts of the resins also. So heavier part we need to separate the asphalting which is required for the roof constructions. So we need to separate that the asphaltenes material from that vacuum, the vacuum residue. So after vacuum distillation, the propane deasphalting, then the solvent extraction process, where the non-aromatic raffinate and the aromatic are separated out, and then the non-aromatic raffinate again sent to the dewaxing process, the means to recover the dewaxed oil and the slack wax, and this dewaxed oil is again sent to the clay treatment process. After this clay treatment process, the lube oil can be produced, which is means blending based stock to produce that finished lube oil, means whatever the lube oil is produced after the clay treatment, uh, we can send it to the market as well, or if we need to uh, increase the quality for that of that lube oil, for that case we have to blend that lube oil with some additives so that to increase the quality of that lube oil. So these are the lube oil processing. So now this what means what is the lubricating oil or the lube oil and its functions. So as these lube oils mainly used uh, to lube the gear parts, okay, uh, to minimize the friction, to minimize the friction, so that the engine or the gear uh, will function properly without increasing means by uh, minimizing the heat generation, okay, and minimizing the friction. So what are the important properties of that lubricating oil, which are the viscosity, and next is the viscosity index, means the viscosity change with temperature, then the pour point, then oxidation resistance, then the flash point, then the boiling temperature, then the acidity, then thermal stability and color. So these are the important properties for the lubricating oil. Each properties are important because at a means at different weather conditions we required the different uh, means means at different weather conditions the lube oil character will change. So we have to know means at that particular weather conditions means what are the sustainability of that lube oil. Okay. So what is its pour point? What is its oxidation resistance, flash point, boiling temperature, thermal stability? How means how long it can be stable if there is a huge temperature generation. Next is uh, so we elaborate these properties. So the first one is that the viscosity. So as we know that the higher the viscosity, the thicker the film of the oil. Okay. So higher the viscosity, the thicker the film of the oil. However, too high a viscosity may cause undesirable friction and heat. So too high viscosity sometimes may cause undesirable friction and heat. So higher the boiling range of the fractions, usually greater the viscosity. So higher the boiling range of the fraction, usually greater the viscosity. Next is viscosity index. So higher the viscosity index, smaller the change in viscosity with temperature. So if the viscosity index is small, then there will be the smaller change in the viscosity with temperature. So it may a negative or even a greater than 100. Sometimes additives such as polyisobutylene and polymethyl acrylic acid esters are added to improve the viscosity index characteristics. So these two additives are important. Uh, so poly uh, polyisobutylene and polymethyl acrylic acid esters. These two additives are used to improve the viscosity index. Next, the pour point. So for motor oils, at a lower pour point is very important. A lower pour point is very important to obtain easy of starting and proper startup lubrication on cold days. So whenever there is a cold weather, there is a tendency to uh, means to icing that the lubricating oil. So to lowering the pour point is very important things so that the starting and the proper startup lubrication can be done in cold days. Next is the oxidation resistance. So at higher temperature, such as in internal combustion engine, can cause rapid oxidation. So higher temperature in internal combustion engine can cause rapid oxidation. These oxidation cause the coke formation, and this formation of these asphalting type materials. Okay, so whatever the coke is formed due to the oxidation process, this is the asphaltic type materials, and these products can injure the metal surface and can block the flow lines. So additives such as phenolic compounds and zinc di uh, thiophosphates are added to inhibit the oxidation reactions. So these are also two important additives to uh, reduce the oxidation process. And then the flash point. This may indicate that the type of hydrocarbons are present in the lube oil and determine the volatility of the oil and the possible emissions which may cause. So flash point mainly indicates the what are the types of hydrocarbons present in that lube oil and which also determines the volatility of the oil. Okay, so flash point indicate the type of hydrocarbon and the determines the volatility of the oil and the possible emissions uh, means, which may cause. And then the boiling point. Boiling point tells the type of hydrocarbons present also and give an idea of the viscosity of the oil. based on the boiling point, there is a difference in the viscosity of that oil. And next is the acidity. Now the organic acids formed by this oxidation of oil, or that is formed as byproducts in the combustion of oil, may cause corrosion. Okay. So organic acids, whatever the organic acids formed by the oxidation of the oil, or that formed as byproducts, means these organic acids are formed by the oxidations or any process, uh, as a byproduct in the combustion of oil. Okay. So these organic acids may cause the corrosion of the line or the equipment. So therefore we need to reduce that the acidity. So lube oil blending stocks from paraffinic crude oils have excellent thermal and oxidation stability. Which are having the excellent thermal and oxidation stability? Lube oil blending stocks from paraffinic crude oils. So lube oil blending stocks from that paraffinic crude oils, which are coming out from the solvent extraction process. Means after propane deasphalting, then the solvent extraction process as a top product, we are getting that the paraffinic one. So these paraffinic crude oils have, the lube oil blending stocks from the paraffinic crude oils have that excellent thermal and oxidation stability, and which exhibits the lower acidity than do the oils for the naphthenic crude oils. Then the acidity characteristics are determined by neutralization number. So this is the process by which the acidity can be measured. So in the thermal stability, it ensures that the lubricating oil is stable under conditions of the operation and not cracked or reactive. So it ensures the lubricating oil is stable, means the lubricating oil is stable up to which temperature. Okay, so that it not cracked or reactive. And color, reasonably unacceptable color, may a sign of the presence of olefins, metal complexes, and the heteroatoms such as nitrogen. So color is very important parameter. So some lube oil having some color, if the color is changing, so uh, this change in color is unacceptable, because uh, this change may be the sign of the presence of olefins, which is also the undesired products which are having the high oxidation property also, and then the metal complexes and heteroatoms such as nitrogens. So some undesirables characteristics also are there for the raw lube oils. uh, so these are the high cloud and pour points. Okay, uh, that this one is undesirable, very undesirable, with a high cloud and the pour points. Then the large viscosity change with temperature, that is low viscosity index, poor oxidation resistance, poor color, high organic acidity, high coke formation, and sludge forming ability. So these are the few characteristics which is very undesirable for the raw lube oils. Now, what are the process used to change these undesirable properties? Because as we have these the undesirable characteristics of this raw crude oil, so we need to reduce these undesirable characteristics by some process. So these are the solvent deasphalting process, solvent extraction or the hydrocracking process, solvent dewaxing process, or the selective hydrocracking or the hydro dewaxing process, and the clay treatment process. Okay. So these are the process by which we can remove the undesirable characteristics of the lube oil. What are they? Solvent deasphalting, solvent extraction, solvent dewaxing, and the clay treatment. Okay, from the next class, I will describe the solvent deasphalting process and the solvent extraction process. Okay, and means what are the blending processes. So for the today's class, we have just go through the vacuum column. Means what are the overview of the vacuum distillation process. What are the operations? What are the principles? What are the process are going on inside the vacuum column? What are the temperature and the pressure need to maintain? What are the furnace temperature need to maintain? And means for creating the vacuum, what are the uh, means what are the process by which we create the vacuum by that ejectors or the liquiding pumps, or sometimes uh, by single that ejectors or the liquiding pumps, or by the combination of these two equipments also. Then means mainly in that vacuum column there is a demister pads to uh, remove the mist in that uh, paper, and means we are using that the structured packing so that we can increase the superficial area, so that provide mass transfer and the heat transfer also. And then from that vacuum column we have some vacuum residue, vacuum gas oil, which we send that the uh, through several treatment process, and which is hydrocracking or the catalytic cracking, or the lube oil processing. So today we just discuss the lube oil process units. Means whatever the vacuum gas oils or the vacuum residue comes from the vacuum column, it need to send to the deasphalting unit first. Then it has to pass through the solvent extraction process, then the dewaxing process, then the clay treatment process. Okay, and then we get the final oil one. And for further uh, quality improvement of that product lube oil, we can blend it with some additives. So means what are the characteristics of the lube oils? What are the main properties means, uh, wi- means, responsible for the lube oils? So means if somebody ask you, means what are the characteristics you need to measure the quality of the lube oils. So what are the properties? So what are the definitions of, of those properties, and what are the undesirable characteristics of those lube oils, and how it can be okay. So there are the some process by which you can remove that the undesirable characteristics of that raw lube oil. So next day we will discuss the solvent deasphalting process, solvent extraction, solvent dewaxing. Okay. So thank you for the today's class, and if you